Thank you. There it is. So part of this, since the topic was on convergence and collaboration, I'll set a little context. I'm from a platform company, and we're now a large platform company because we buy about 15 to 20 companies a year. If you buy 15 to 20 companies a year, you'd better get good at convergence. So part of what we've had to do is make sure as we're building the software stack, the database and things added to it, that this will help absorb the companies that we're acquiring. And part of what we're doing when you acquire somebody is first you collaborate with them, make sure this is working. And as I'll later point out in standards, Oracle has a commitment to standards from the top to the bottom of everything that we build. You make sure that they were following standards. That makes the convergence a lot easier. So there's two fundamental kinds of convergence that we all live through. One is mandated, meaning you got acquired or two companies are merging for various reasons. Government departments get merged. Basically if you're the mapping authority, not the mapping agency, but also the land registry or statistics, and you're told by the head of your country, you're going to merge, now you're in convergence. Or policies are set, such as the place matters that was currently mentioned. And then there's voluntary ones, where industry partners are collaborating together, but you've got to learn how to share the data and work together. And then there's actually a series of these that are private enterprise, plus government, plus academia to work together in some collaborative fashion. And it's due to the many new and various types of data. So now I'll go through a busy slide on what that means. And in the case that we're dealing with at Oracle, you hear a lot about big data, but really there's also going big hardware and big software. And by that, the big data terminology, many people have mentioned, this goes through your sensors, RFID, video, LiDAR, things that we're all familiar with, all of the social media, the growing Internet of Things. There's multiple billion already things connected together that we're trying to deal with. And then added to that is keeping a history of what's been happening, the archive type and versions of data and multiple copies of these. The same thing on things that come at a large level, software data infrastructures, Inspire, linked open data, which demands persistent relationships between data. And this is where you get into the topic of semantics and ontologies, which is undergoing a great deal of active development and capabilities. All of these are on the data management relationship side. We talk about the cloud. There's public clouds such as Amazon, meaning you put it out there, but you've got to trust everybody else. It can be shared. Or private, meaning you own all the hardware, but it's still a cloud infrastructure. And this is because you're able to handle massive, parallel, low-price machines. You can do clusters ganging to 10 to 100 to 10,000 clusters. In our development clusters, we've got, and there's multiple nodes, 10,000 machines in each one. So basically, this is the level of ganging together of hardware that's making clouds be possible. In addition, you can take the multiple parallel and do the software enable it like the Hadoop, where you're finding it in parallel. You can then analyze huge amounts of things in parallel, shrink it down, get rid of the noise, get it down to the signal. And usually this is 1,000 to 1, 10,000 to 1 compression down into, this is the part I cared about. And finally, this is where it's big software. Because we're the spatial world, think of all large applications are being spatially enabled. The ERP, CRM, everything that we're shipping out of Oracle that's an application now has a spatial column within it. The same thing with other people in that business. Thus, the spatial capabilities are being spread out, but also real-time analytics, where basically you've got to, if you're going to collaborate with people, handle real-time things that are showing up at the microsecond level, being filtered them, being ready to make decisions on what do I keep, what do I not keep. Security comes up, both you've got to protect your data if you're going to converge with people, how are we going to protect this, as well as how do you defend yourself against the hackers, supporting standards, which I've talked about there, and then an entire stack versus build it yourself. So in even less time than I took to present that slide, of 60 seconds, there was about 170 million emails, probably several sent right from this room, ignoring the Twitters. At that pace of data showing up, you've got to have the tools, and this is where you get into collaboration tools, where you're going through and looking for anomalies. Is this the information I wanted? I've got a lot of sensors out there, but did they change? Is it a change that I care about? So you've got to be looking for your anomalies. This has also got to do on the banking side with ATMs coming in where you're trying to figure out fraud detection. Are these things related? The association rules that you're trying to analyze, again, in real time. This is where you see the commercial world, retailers. As you walk through a mall, they're detecting where you are, what you used to buy, and they're, up to your smartphone comes an advertisement if you've enabled the advertisement. Clustering these together, saying, okay, yes, this is complex event processing. I've got this happening and this happening, but not that's happening. Okay, that matters. Let's collect this data into a demographic area. And this is what I'll persist or what I will not persist, as same with getting other attributes about it. However, and this is the point on big data that needs to be made, you can't keep it all. There was a discussion earlier, and I don't mean to go against you. Person doesn't delete the email. Yeah, your email's fine. It's not that much data. The human race is going to generate about 3.5 zettabytes this year. By 2020, which is only 7 years away, it'll be 35 zettabytes of data. So it goes terabytes, petabytes, exabytes, zettabytes. Guess what? We don't make that many disks or tapes or optical storage, and there's no plans to. There's no technology I know of on the horizon. So that means in your world, you've got to be making policy decisions on what am I going to keep and what am I not going to keep. The driver of this really is going on is whoops, that was the wrong one. Is really the drones, but this is an audience that is going to see more drones flying for mapping. The story I tell a little bit that I can't repeat too much is the U.S. Air Force, who has a lot of money, could afford a lot of disks, they fly a lot of drones. Think about getting 100 petabytes a month showing up. Where are you going to put that? So even though you're supposed to store it, you can't, so it goes away. So basically, no one will say that publicly, but you just simply can't do that. Where would be the electricity to drive 100 petabytes every month and keep adding that to some facility? So know that, in spite of somebody saying, keep everything, you really can't, but you need to keep archives, so think about that for a policy. And again, to support that side of a workflow, we have automatic, we've had this because people ask for it, automatic archiving from hot data that you want to take care of, medium speed, and cold. And so what's the difference? Oh, it's one of those things, a build. Somebody else's slide. The hot data means you expect in 30 days you're going to be using this a lot. We'll give you about a 3-to-1 compression. Warm data, and this is about a 10-to-1 type of a compression. This is where you get an important point on sharing data, is because you can't keep it all, and each department can have their own copy of it. If you're in a government agency and this department, they get this portion of the data, the other one gets that portion, you must repurpose it. You must have a layer so you can share the data. This has got to a shift in workflow. You can't pull everything to yourself. I can live in my own world and not worry about the others. You really can't. One, there's the cost side, but two, physically, you simply couldn't keep all of that data. So this is where you get to the middle tier, and finally, if you really want to archive it, we'll give you a 15-to-1 compression, but that still means you can leave it on the disk. It's just that you don't expect to archive it except in data mining. Again, people come up, we need that data around because maybe 2 or 3 years from now, our data mining capabilities will be good enough, we can sweep the data and find new treasure there. So basically, these are a different kind of a workflow. As you leave the data sitting on the same disk, you just set up a poly. This is my hot data. This is my middle data. That's my cool data. These are just policy decisions. We'll take care of the work for you. We're not the only ones, but this is a trend. So this in the middle is the person that's you or somebody that works for you. And they're sitting in this world where underneath them is all of the geospatial data as well as all the other classical data, your historical data, the demographics, call centers, whichever kind of text documents. This is in a persistent store. We would hope it's ours, but it's a persistent store that handles all the different data types, and that way you can share it easier. But showing up is all of this is your social data, this is your real-time data, or things coming in that you mined, coming in from transactional databases, blogs, etc., Facebook things. But then also on the top is your real-time data sources. This is where you've got your electrical meters, your sensors coming in that can tell you, whoops, you've got a problem here, you better check with that. The same thing with instantaneous weather, and you've seen various presentations today. The system has to be able to process that and handle it in real time by this person, mapping it against this for comparison, or what action to take, and then finally responses that are going outside saying, all right, if it's an electrical thing, what's going on with the grid management? How do we respond to that instantaneously? Your varieties of others, what you're saying, this is where you're serving your customers in real time, not just in static levels. Helping with that, and this I'm going to start with this one because most of you are familiar with ontologies, in that if you've got a data set in the mapping world or geography world, you had to settle on geographic names. This has been both a research topic and a considerable negotiations, but an ontology can give you the support to settle on geographic names so you can share data and then create national map schemas, temporal, etc., whether you're dealing with situational Americans, disaster recovery situations, etc. So here's the bigger picture slide. How do you make it possible to share data among many departments or many bureaucracies or stovepipes, you've heard all of those terms today, without rewriting everything? Well, at the top layer, so these are the people, let's just call, you could call them the stovepipe, each individual department, same thing in corporations. One group says, yeah, I got my relational data and I got 30 years of history here. I can't possibly shift that quick. Here in the middle, this is somebody using the new Hadoop on the big data. It says, yeah, but I've invested in it a lot, and I've used this for security and data mining. And over here, somebody says, no, I use NoSQL. That's my real-time stuff. I'm married to that. Up above are all the people trying to get the work done, whether you're doing either the data mining and analyzing the types of data that is coming from here. But up here are the people that work for you. Okay, so there's basically, there's the operational people, there's your data scientists that are really trying to go through and find new value out of the information, people writing new code. You can create a semantic metadata layer here. And this is where, I'll use the name of somebody that often gets quoted here is Tim Berners-Lee when he talks about the semantic web. Because some of the, again, first, the internet and the web made a huge shift in the industry. If we can get the semantic web fully operational, that's the picture that you're looking at. So we've invested a great deal in semantics and ontology support so that people can use this on top of all of their data. There's the human side of trying to get groups to work together, and then what can we, technologists, provide to help make that happen. And this is our best offering to date in this area. As you can do that, then your cloud can get linked to other clouds, and this is getting mandated. For example, you've got the Uniprot, the proteomics cloud, also talking to the gene ontology cloud. So basically, these can then communicate with each other as you solve the metadata and the semantics issue. This has been brought up multiple times on security. If you're trying to do convergence of groups or collaboration, you really have to settle on a security model. You need the ability to have encryption of everything that is persisted at different levels, depending on who's going to be trying to acquire it. And in fact, what we call the database vault, when you use the database vault, the database administrator can't even get in. okay? The CEO may have a key and a certain special person will have a key, but even the database manager can't get into it. So this is the level that you want to go into. Then also, and I talk about mask and redaction, the issue of privacy, another build, raises the question, and this can vary by location, is what is somebody allowed to see of data? What's really going to be honored by privacy by your country laws, but perhaps not by the country next door? Or your organization, you've got 3 organizations, some can see data, some can't. And this is where redaction comes in. I'll just talk through it, assuming it's just one company. And you've got the sensitive data, and in the United States, that's your Social Security number. But it's whatever, I'm sure within each country you've got some special key that you're working on. So payroll needs to know that is, so you can get your check, and we'll all let them take a look at it. However, if somebody's just a call center or calling up, you can redact the social, in our case, a certain number, and only reveal the last 4, which is usually used by banks and other places in America. How do we validate you? They take the last 4 digits of your credit card number, or your date of birth may be just completely blanked out, saying, okay, we'll send you back as January 1st, 2013. So redaction, and this happens in real time, so that you can force it to be permanent if you want this to be the same way everywhere, or you can say, okay, in Holland, these are the rules. In Germany, those are the rules. In the United States, those are the rules. And you let your redaction adopt this for you. Again, this is technical support for the privacy question. You can tell some of these slides I'm not. And of course, with the cloud, as I have to describe, we provide public cloud, private cloud, whichever you're looking for. Standards. And again, we endorse all standards. If you really want to get into convergence, collaboration, you've got to make sure you're talking to somebody else that's supporting standards. Otherwise, you're going to have a difficulty. An active area right now is tagged metadata. I was just in a conference on this 2 weeks ago. And these were this is an American intelligence community. So, they're supposed to be talking to each other. So what they did is they agreed on some metadata. We think about 300 metadata. They tagged the data itself. It's not the shared, but you put tags and then you can search it. Well, so far, they had agreed on 7 tags among 5 organizations out of 300. Said, guys, is this as fast as we can go? Is this my tax money that's paying for this? So, that's another area of standards going on. So these are down to my last slides. If you're for true convergence, and this is what we've tried to build for the world, is you've got to be able to support all of the data types of the big data, the way that it arrives, simplified. Big data with those. Spatial, like so you support spatial, we support, for example, medical imaging gets stored natively in an Oracle database, as do all data types. The analytics that go with it as you're trying to search for meaning on this, the cloud engineering system. Okay, thank you.